Begin. So so this was for my undergraduate dissertation thesis. I did an investigation, this is the title of it. It was into the Macrophyte and Algal Biodiversity above and below the Milton under Wychwood Works. I also looked at the water quality within the area as well, but I'll just take you through some of the research I did. The background, I'm sure most of you will be quite aware of. It's kind of a general overview. Biodiversity is declining globally with fresh waters. Very, very quickly declining, unfortunately, and in the UK, river status is very, very, very poor across the entire length. Eutrophication is a rising source, and wastewater treatment works are evidently in the media nearly daily at this point. However, the impacts of them on riverine diversity, particularly with macrophytes and with the algae side of things, is not very well known. It's quite difficult to be tested by citizen scientists. So I wanted to have a little look at if I could see the impacts in an area where water quality has been quite bad. This was just background. This is also a presentation I gave to my final grade for the dissertation. So there's some background in here that we should be aware of, but yeah, just saying that within the Milton under Wychwood there had been complaints risen about the wastewater treatment works there. So the aims of my investigation in particular was to see whether it was altering the nutrient levels, which citizen science data has suggested, and I carried out a secondary analysis of John Pratt's citizen science data as well, to see if it agreed with my findings. See if it was impacting the levels of algae, so that's both phytoplankton, so microscopic algae, which should indicate algal bloom risk, and also macroalgae on a kind of diversity scale, and also if it was impacting plant diversity and the composition, so what species were around. So methodology, so it's quite a small little figure here. I don't know if you can see it, but I've pinpointed in little green dots the sites where I carried out analysis. So there were 6 sites, split evenly upstream and downstream. So TOP is the outfall pipe on here, and we've got USS upstream and then DSS downstream. And at each site I carried out 5 meter random samples, measured just tape measure, the number of which was just dependent pretty much on accessibility and whether I could get permission to access the land, etc. But at each site I carried out quite a lot of data collection points. So I carried out diversity measures, so I did percentage coverage by eye. I also took some water samples back to the lab with me to do some analysis, and tested for some abiotic variables such as depth, temperature, just to see if that could be driving any of the results that I found rather than the outfall pipe. So the outfall pipe I used as well, it's the treated effluent pipe. Just for context. So in the lab, I tested for phosphates. This is my little lab space and my little picture in the top right-hand corner there. I also tested for nitrates, and I tested for the phytoplankton. So that's via chlorophyll A. So that's once again the microscopic algae within the water sample. And then data analysis. General exploratory, seeing comparisons upstream, downstream was my predominant kind of comparative methodology. NMDS, I'll discuss more in my results, but that was basically looking at whether there was a composition, whether there's correlation between what species of algae and plants were occurring together, if certain ones occurred downstream, certain ones occurred upstream, and then also significance tests to see if there were significant differences. So results. So here I've kind of paired my results together. So on the left-hand side, we've got the phosphates, PO4, and the nitrates, NO3 on the y-axis. And on the bottom, we've got flow, so US upstream, DS downstream. So the left-hand side graph is box plots and my results from my water quality that I lab tested. And on the right-hand side, I've got John Pratt's results, which were from similar sites, or as close as I could get to my sites within the area. So from here, you can see that the y-axis on both mine compared to the citizen science is very different in scale to begin with. So on my result, the phosphate, it goes up to 10 milligrams per litre. whereas the citizen science only goes up to 0.9. There is a reason for that. I'll bring it up in a minute. But my main findings here were that phosphates were significantly elevated by a lot. You can barely even see the upstream bar chart in that graph I've got displayed there because it was so small compared to the downstream levels. But it was significantly elevated. Nitrates from my water samples were not significantly different, but they were very elevated both upstream and downstream of the brook. They just remained high. Citizen science, none of them were significant, but once again, I'll come back to why I think this probably was the case. But nitrates, once again, were high in the citizen science data, and phosphates are still classified as high. So with my results from my samples, so we know that effluent from wastewater treatment works can be high in phosphates. And even though this was from the treated effluent pipe, I've got some pictures here that I took in the field with the pipe just behind this kind of reed growing out. But there was black water actively discharging from the pipe, which can be seen kind of down to the bottom, which is probably why the phosphates were so elevated. It had been reported to the Environment Agency. But yeah, and then there have been findings that wastewater is treated less rigorously within smaller communities. And this treatment works only has 2 pipes as well. But then why were nitrates not high if there was black water? Well, nitrates aren't released as nitrates. It's nitrogen within wastewater or black water, which is untreated waste. And there tends to be a lag before nitrification occurs, so before this nitrogen gets converted into nitrates. And this just depends on things such as the number of nitrifying bacteria, which tends to increase as you move downstream, and other things. And then just a little bit on the citizen science. So I've got an image here from Freshwater Watch of the test kits for nitrates and phosphates, as I'm sure many of you are familiar with. And one of the main limitations here is that the phosphate measurement is capped at 1 milligram per litre. And I was getting readings of 9.2 around the outfall pipe, so quite a lot higher than what can be tested for by the citizen science test kits. And the mean upstream was 4.65, so the average was way above the amount anyhow. And then just for kind of reference here, I've got the ecological status classifications of phosphate and nitrate measurements, just to show you that every single box plot that I plotted was above, was in poor levels for everything, pretty much. That's the next one. So now just a little bit on the algae test. So here we've got, this is for the microscopic algae, the phytoplankton. So it's measured as chlorophyll A on the y-axis here. And we've got flow once again, same on most of my box plots, upstream, downstream. But this wasn't significantly different upstream or downstream of the works. It was still moderately, it was quite low. It wasn't too bad, but it wasn't significantly different upstream or downstream. And this once again is due to, like with the nitrifying bacteria, there's normally a lag. So for this phytoplankton to accumulate and to see a bloom, which have been observed in the main river Evenlode, there's kind of a delay, there's a lag before we see these blooms actually occurring. It needs a slower moving area of water to accumulate and then drive that bloom. So we have seen that the nutrient levels are high enough for a bloom to occur. So it's just likely that this would probably occur further downstream. This is now looking at the macroalgae, so that's the visible algae you can see on substrates, on rocks, etc. So on the y-axis, species richness, so the number of different species, upstream, downstream. So for this, the result, I used RAPA, so the rapid assessment phytoplankton, which some of you might be familiar with, which, to summarise, it's a species percentage coverage by eye, but then you identify the algae by texture and look. It is very difficult. It's very, very difficult in the field, and it's just very slimy. So that was a lot of fun. But there was no significant difference between the number of macroalgae upstream or downstream. And my NMDS model, which shows if there's correlation between certain species upstream and downstream, there was no it was a really poor model. It was not fitted very well at all. And this is just probably because I didn't take, there weren't many kind of families of algae that I could identify, which is probably what drove a really poor model and no significant difference. But despite this, Vaucheria genus of algae occurred at all upstream sites and most of the downstream, which pairs with my results of the high nutrient findings, because this is classed as a competitive taxa under RAPA, which means that it can thrive in high nutrient levels. So whilst RAPA here didn't particularly show, I guess, the difference in number of species in my study, it did still show that there was high nutrient levels and certain families that occurred supporting that. So the macrophytes told a completely different story. So once again, I've got species richness, number of species on the y-axis, and upstream, downstream on the x-axis. And this time there was a significant decrease in diversity, as measured as species, number of species here, downstream of the outfall pipe. So this was significant, and this was also patterned with Simpson's diversity, just a measure of how diverse the area is. Also showed this drop in diversity going from 0.5 upstream to 0.2. It's measured on a scale of 0 to 1. So it dropped downstream as well. This is probably because species which can exploit high nutrient levels were potentially existing downstream, and they kind of become dominant within their communities. They exploit this high nutrient level and they overtake, so we see a decline in diversity. However, with plants, it's important to note that even though the nutrient level high could be boosting growth, habitat is also really key in determining what species of macrophyte we're going to see occurring. It could just be that the area was more shaded. It could be that there's more exposure to the light. There was something else that was allowing them to thrive. So I looked into this a bit deeper, and I looked at what species I actually could observe upstream and downstream, and an NMDS model, so once again showing me certain species occurred upstream versus downstream, showed that there was clustering of certain species upstream and downstream. And this table on the left-hand side here, on the left-hand side I've got the upstream species, and on the right-hand side I've got the downstream species. And when I looked into these species, it showed that maybe disturbance could play a role in what macrophyte species I was observing, as it's been showed that in areas with reduced disturbance, both anthropogenic and natural, macrophyte mass development can happen. So that's when one species dominates and we see a drop in diversity. So just to go into some of the species, so upstream, where there was increased disturbance in my study, so where one of the sites was at a petrol station, so large amount of anthropogenic disturbance. I saw species that were pioneers and edificators, so they modify their environment, which means that loads of different species can occur there, and they tend to be temporary communities that are not as well developed, and they're constantly replaced. And downstream, where there was decreased disturbance, so this is in farmers' fields, etc. I saw plants with quite with adaptations to developed communities. So ivy with its adventitious roots, it climbs up trees. It depends on a dominant community, something that's well established. And also the Bryophytus, so the moss, that's capable of surviving in really high nutrient levels due to stoichimeric homeostasis that it can carry out. So just some limitations. On the left-hand side here, we do have my drenched field notebook from the first day when I tried to use paper and found out that was a very, very terrible idea in an outdoor environment. So the major limitation is that the sampling area was quite small. There were 9 downstream samples and 6 upstream samples overall. And this was predominantly due to time constraints. I didn't have much time to carry out field work. And with it being an undergraduate dissertation project, there's not much allowance on how much fieldwork time you can have. There was a bias to accessible sites, even though I used random sampling to try and counteract this. It just depended on how I could access it. I mean, we did tread down water quite far, but it depended on how much we could access. And then the other major limitation is with the algae side of the investigation here, RAPA is incredibly inaccessible to citizen scientists specifically, was one of my major conclusions. It's very difficult to carry out in situ in the field. due to overlap in many textures, and if you've not been familiarised with how to identify them before going and trying to identify them in field, is very difficult. But it's something that could be developed to indicate algal bloom risk in the future. Wider implications, so socially, supporting citizen science agrees with the increased phosphate levels specifically, and suggests that algal bloom is a risk within downstream of the Milton under Wychwood sewage treatment works. Results presented to the ECP, so that's me here today. And it also agrees with the Independent Water Commission that I'm sure many of you have seen, that was published about a couple of weeks ago now at the start of the month, stating that the Environment Agency is going to need increased funding to respond to these increased disturbances in wastewater treatment works, which I saw firsthand when the Blackwater was discharging. We called the Environment, just a little bit of a side note here, but we called the Environment Agency, who contacted the treatment works, who denied there was any discharge from the sewage pipe, and we got sent back there and it was still discharging Blackwater the next day. So just it clearly agrees very clearly that there needs to be someone sent out on occasions where possible. Scientifically, it once again just supports this overall vast research gap in freshwater biodiversity. There's not many studies into biodiversity within rivers, and most of them do focus on the invertebrate, the macroinvertebrate community, which is still important. But specifically to citizen science as well, there should probably be some way developed to analyse algae in some manner. It also shows that broad catchment experiments are needed, because, for example, in this study I show the high nutrient levels and the algae that occur in high nutrient levels, but if there was going to be a bloom, it's likely going to occur much further downstream. So doing an isolated study in this way can be useful, but it needs to be paired on a much larger scale downstream. It also shows that preventative measures are needed, which is easier said than done, rather than just dealing with the consequences when it's been described as a ticking time bomb, particularly with the phosphate and nitrate levels we've seen in this study. And it's just a matter of time, really, before we start to, well, we're already seeing the impacts, but we're going to continue seeing them. So that links back to the title of my investigation: is anything that is out of sight truly out of mind? Thank you. Does anybody have any questions at all?
Well, thank you, Rachel. I was going to come to that. Fascinating bit of research. Thank you very much for sharing it with us. And difference between algae and macrophytes. That's interesting to hear. And your brush with citizen science as well. Interesting, all interesting stuff. I would imagine that there are one or two questions out there, so let me ask people. I think we've got a hand raise button, so if you've got a question, perhaps use that, or just shout out, and perhaps Anne and Stephanie can help me spot whether there are any raised hands. Nick, I've got as a raised hand. Nick Mottram.
Thanks, Frank. Shall I kick off?
Yes, please do.
Fascinating, and my non-aquatic brain struggling to keep up at times. Yeah, really interesting. My question actually might almost not be for you, but it's triggered by what you're saying. And maybe it's Sam or Anne or someone else might be able to help. And the point you made about the citizen science kit being capped at, I think we said 1 million per litre. It just made me think, why is that, and is there anything that can be done with the citizen science kit in order to widen that level of phosphate measurement? I'm sure there's a reason for it. I don't know what it is.
Yeah, that was very muffled, but I think I got the gist. Were you asking about the citizen science kits and whether anything could be done to modify them so that they can get a higher reading? So I'm not sure. I didn't actually use the citizen science kit within my study. I don't know whether it's because of the quality, the kind of subjective nature. I'm sure someone else has a better answer than me probably for this on the citizen science thing. But it was a very shocking result that I was not aware of. It was after I got the citizen science box plots and they were so drastically different, I was quite shocked. And then I talked with my supervisor, Izzy Bishop. I'm sure a lot of you will know her. And she said, yeah, this cap is definitely one of the major drivers. I hope that something can be done about it in the future, because it does make the citizen science data a bit, not intentionally misleading, but it vastly underestimates, especially when we're getting readings that are, you know, nearly 10 times the maximum cap of the level that can be tested with citizen science. So I'm not sure if anyone else in the group knows if there's anything that can be done about this, but it is very shocking. It's something definitely needs to be done about it, because it does not show the extent of nutrient enrichment that is occurring within the catchment.
Yeah. Thank you, Rachel. I mean, absolutely not a direct question for you, really, because of the citizen science kits. And I think, you know, we have known about this as a bit of an issue, but even with the if you like, the low thresholds on the citizen science kits, we know it's bad.
Yeah.
All you've done is told us it's actually a lot worse than your records show it to be. So that's an interesting observation. Has anyone got? Can anyone tell us about citizen science? Caroline.
Yes, thanks. Just put my hand up to respond on that. I think we probably can't badge all citizen science in with the Freshwater Watch kits. So yes, the Freshwater Watch kits, it's low range phosphate that we use. That's because we've got a standardised methodology that's used for community groups across the globe, and in other places people are right at the very bottom end of that scale and asking, you know, if there's anything lower than that to detect phosphate at lower ranges. So it is quite hard to have a one size fits all situation. There are other citizen science tools out there. So what we did buy at the end of the Smarter Water Catchments project for ECP, we've bought some phosphate hanometers and hanocheckers, so they will have a different range on them as well. So it could be that we want to roll those out a little bit more across the catchment to get people exploring them. But as you said, Frank, it's still, you know, it's still the phosphate range that we have does still cover kind of good, moderate and poor. So if we're categorizing things, it's poor whether or not it's 1 or it's 10, but I do appreciate the point. Yeah, absolutely.
It's poor, but sometimes it's probably dreadfully poor, and we don't really appreciate quite how badly how bad it is. And none of that, of course, I would have to say, is a reason not to do the citizen science testing in the way that we do the citizen science testing, because we are collecting valuable data and gaining useful information. Good. Can
I just add something? Is that all right, quickly?
Yeah.
Just to go in further with my lab testing of the samples, I did have to carry out dilution series for every single phosphate sample that I tested as well. So even the machine within the lab couldn't test high enough for the levels of readings that I was getting from the river. So
that itself is an interesting and telling point, isn't it? Yeah.
Frank, we need to send off one of your samples. The colours that you get are always beautiful.
Just for information, my sample point is, I don't know, 100 metres down from Morton in the Marsh sewage works outfall into the Four Shires Brook. And sometimes it's not too bad. Sometimes it's just off the scale. And it's always absolutely gin clear, you know. See-through water is not unpolluted water. I have to keep reminding myself of that all the time. Good. Any other questions for Rachel? Not seeing any. So, Jennifer. Jennifer, far away.
Rachel, sorry, I was really interested in the total number of macrophyte and algae species that you were able to identify.
Yeah, okay, I'll just slip back to my slide. So yeah, so for these ones where we've got n equals, let me have a little look, 1 second. So this macrophyte table here, this is all of the plant species that I identified in the field on this table. So I'm gonna have to count them now, I've forgotten. But there's quite a handful of them.
12 and 9.
Got 12 on the left-hand side.
21.
And 9 on the other side. Yeah, so about 22-ish species of macrophyte. The algae was drastically lower. There was really not many. It's measured at not at species level with the macrophyte. It's measured because you would need microscopy to identify it to species level, which I didn't have time for in this study. Definitely could be done in the future though. But I think I only got about it's genre level that it's identified. Here, I think I only got about, it must have been 3 or 4 species or families of algae. It was not many at all, but that is how they identified in RAPA as well. It is at that level, and they're kind of more so than the classification. They're grouped more so into good guys and bad guys. So competitive and stress tolerant, or stress adapted. And the competitive taxa are the kind of groups of algae that we would see in really high nutrient rivers. So they do act as a really good indication within RAPA of eutrophication risk and algal bloom risk. If we're getting loads of competitive taxa, we know that there's a real issue. And if we're getting stress adapted, it's not as worrisome. And within this little not at risk, this little table that you see in the bottom left here, this is directly from the RAPA original paper from 2016. And if you analyse the percentage coverage of C taxa and S taxa, good guys and bad guys, that can tell you how at risk the river or stream can be classified as with regard to an algal bloom as well. And it has been shown to be very successful in determining that, at least in all of its field trials in Scotland. And I know there's been quite a few attempts to move this to citizen science, but they've not been very successful as of yet with its specific identification. But they have been successful with the eutrophication risk side of things. So it's still very useful, it just needs a bit more of clearing up.
Good. Thank you very much. Fawn.
Yeah, just a couple of quick points. It's telling that none of the macrophytes identified are truly submerged macrophytes. They're not true aquatic. There's some marginal species and there's some terrestrial species. So just the absence of anything submerged in the river is interesting in its own right. You've got, iris mentha, they're marginals. There's no true aquatic apart from probably Will Ripper upstream. But the other thing, really, I suppose, just is for Rachel as much as anybody who's starting their career. It's great work to look at impact of poor water quality on biodiversity, but it's a classic tactic of the polluting water industry to always want you to look and find the evidence, and the evidence, is clear in Rachel's water quality samples, and we must all never fall into that trap of or it could be this, it could be that. And there is that risk. I mean, we're looking now at shading and habitat types, and blah, blah, blah. The evidence is prima facie. It's there in the water quality samples, and as such, that's what we need to focus on as people and as individuals, as groups.
Yeah. Thank you. And just to note that I see that Owen's popped a macroinvertebrate link into the chat, if anyone wants to follow that up as well, from John Pratt's data. So, it's all just fleshing out or painting the picture of the state of the catchment. And I think, Rachel, you've corroborated things that we've been concerned about here. So Good. Not seeing any more hands, am I? No. Okay, well, if there's no further questions, can I say thank you very much, Rachel, for your time and for sharing your work.